Now next question, okay, this is a factual question. What is the memory size of the STM32? Okay, so this one, okay, let me show you where to find the answer. I think it's chapter 2, okay, if I'm not wrong. Key feature, okay. This is the part, okay, let me zoom in a bit. You can see that for flash memory, 128 kilobyte. For RAM is 20 kilobyte. Okay, so 128 flash and 20 SRAM. Okay, so RAM, okay, should be 20 kilobyte. Oops, I think, oh sorry, it's asking flash and RAM. Okay, so 128 20. Let me confirm again. Okay, 128 20. Okay, so you should choose B as your answer. Okay, question 11, yeah, B is the answer. Okay, now next one, according to the hardware setting of this new F103RB, which is the one you're using, oscillator clock supply should be, okay, this is a factual question. Okay, high speed external 8 megahertz. Okay, choose this one as the answer. There's a memory question. Actually, quite a lot of the questions are memory questions. So if you get the same question in the MST, okay, it will score you some marks. Okay, which one is a digital input? Servo is an output. Okay, servo motor can turn over 180 degree. Okay, answer of course is this one. Okay, normally closed switch. Okay, most switch are normally open, so when you press it become closed. But there is another class of switches normally closed. When you press it become open, but there is still an input. Okay, digital, that means it's either closed or open. Okay, two states only. Potentiometer is analog. Okay, because you can turn over maybe 0 to 3.3 volt. 7 segment is an output. Okay, so B is the answer. Okay. Wait. 11 is B. Okay. Okay, next question. Now, how many GPIO pins are available in this microcontroller? The answer is 51. I think I mentioned somewhere in the past. Okay, you have actually okay, you have port A. Okay, you have port A. Okay, with 16 pin. B is another 16 pin. C is 16 pin. Then D is 5 pin. Okay, so if you add up, this one should, D is 3 pin. So total is 51. Okay, so this is the total number of pins that the microcontroller have. Okay, so let me go back to this one. Okay, the next question is, we want to connect an LED to a microcontroller. Which one is the correct way to do this one? Okay, there are a few things. Okay, I just show you. Okay, when we want to connect LED to microcontroller, how to do it. Okay, so one thing is, okay, let's say this is your microcontroller. Okay, this is your STM32. Okay, and then you want to connect LED. The LED can be connected this way. Okay, you connect this way. This way. Okay, this is of course the anode and this is the cathode. Okay, this resistor is to limit the current. It can be a small number, 470 ohm, 330 ohm, 150 ohm. Okay, all these are small number. Okay, but this pin, let's say I'm using PA0. Okay, this must be made an output pin. Okay, this is one way. Okay, and then when you send a high, okay, if you send a high or logic 1 or 3.3 volt, the current can go this way from A to C. Okay, and the LED will turn on. This is one way. Okay, now of course there is another way of doing, which is to reverse the connection. Okay, you connect this way. Okay, connect this way. Of course here now you need a high voltage. Okay, maybe 3.3 volt. Okay, this one is again a small resistor. Okay, now you have to output a 0, okay, for the current to flow from high to low. Okay, and the LED will turn on. Okay, so these are the two common connections. But always remember to put a resistor. Okay, So the question asks you which one is correct. First one, okay, you need to configure it as an output, not input. Okay, input is wrong already. Second thing, this one is a bit tricky. I was tricked by this question also. It's saying 470 kilo ohm. Okay, it should be 470 ohm. Okay, or it can be 330, it can be 150, but not kilo ohm. Kilo ohm, no current will flow. Okay. Now, this is not the answer. This one also not the answer. So let's look at this one. LED negative terminal must be connected to the ground. Okay. Actually, the answer should be none of the above. Okay, just tell you why. You see, this is the cathode. Now I'm connecting the cathode to ground. I'm connecting the negative. Okay, cathode is the negative. I'm connecting to ground. Okay, so okay, there's a fire alarm going on. Let me pause for a while. Okay, let me continue. The false alarm. Okay, now in this case, the negative is or the cathode is connected to ground, but the negative, which is here in this case, doesn't have to be connected to ground all the time. Okay, that's why you see the answer here. Okay, must be connected, not true. Okay, depending on whether you are connecting, okay, in the top diagram or bottom diagram. Okay, depending on whether you're connecting this way or this way. Okay, so the answer is none of the above. Okay. Okay, question 16. Okay, we are about 1/3. Actually, the questions towards the end are harder. Oops, another fire alarm. Let me pause it. Okay, let me continue. Okay, the fire alarm has been turned off. Okay, so this one, there are two circuit here. Okay, two circuit. There's a button connected here with a resistor 5 volt, then ground. Okay, so this is to microcontroller pin. Now the other one, they just swap the two. Okay, button on top and 10K resistor at the bottom. Okay, both these two are button connection. Okay, but this one, when you press the switch or the button, you're actually shorting the two. Okay, and then this point will be low. Okay, when you push, it becomes low. So this is an example of active low. Okay, when you release, okay, you're not doing anything. Okay, you release, you're not doing anything because it's a normally open switch. Okay, and the point here will be high. Okay, so the thing is, when you press, okay, when you activate, it becomes low. This is called active low. Okay, this one on the other hand, when you activate, when you close the switch, it becomes high. So this is an active high connection. So it asks you, left hand figure. Actually, why LF? Okay, maybe left. Okay, left switch is active low. Okay, and right switch, okay, should be active high. Okay, so low here and high here. Okay, so this B here should be the correct answer. Okay, correct. B. Okay.